Hey guys, welcome to Unfold Data Science. My name is Aman and I am a data scientist. In this particular video, I am going to explain about LightGBM, which is one of the famous boosting algorithm and also a competitor to other boosting algorithms like XGBoost and other boosting algorithms, right? So we will try to understand what makes it faster training. So all these claims you can see here in the documentation, right? Higher efficiency, lower memory use, better accuracy, support for parallel distributed and GPU learning, and capable of handling large data. So what makes this algorithm so smart, efficient and fast? We will try to understand with some simple example. So let me take you to my note here and I will try to explain you a few things, guys, so that you will understand LightGBM in a very easy way. Okay. So guys, LightGBM is one kind of boosting algorithm. Okay. So I'm sure many of you would be knowing what is a boosting algorithm. So boosting algorithm is nothing but it is an ensemble technique where you have multiple models M1, M2 up to Mn, and let's say you start 100 records. So first you will have a M0, which is a baseline model. You make prediction on these records, and then whatever errors you get, E1, E2, E3, on these errors you train the next model, and then so on and so forth. In the end, you combine all these models and take the final model. Okay. In boosting, there are many models. Okay. Some of the famous ones are AdaBoost, you can say gradient boost, and you can say extreme gradient boost. So as I'm writing these, guys, you can see some links here. The reason being, I have separate videos for theoretical explanation of all these algorithms, the Python implementation and the mathematical explanation as well. So you can watch those videos, but here I will explain more about something known as LightGBM, which is another boosting algorithm. So what makes LightGBM so fast, so efficient and so good? So from your data science common knowledge, you will know that if you do some smart feature engineering, right, you can make a better model. If you do some smart sampling of your record, right, you might be able to do a better model or build a better model. So LightGBM does these things using few techniques. Those techniques I'm going to discuss here. Suppose, guys, I give you 500 records, okay, employee data of an organization, and this employee data has, let's say, ID of employee, name of employee, age of employee, gender of employee, and a target salary of employee also, and a target column, target variable I'm calling here. Okay. So typically in all these boosting algorithms, what runs internally is decision trees. Okay. So if these 500 records has to go to a decision tree training, then the first thing that will happen is the root will be decided and then the tree will split. So one of these columns will be selected as a root column and the criteria will be selected using Gini entropy, those things, right? So what happens here is, in traditional decision tree, you will see that, for example, in salary, if I have, let's say, 50, 55, these are different salary values, 60, 70, 80, right? All these values will be sorted and, tested, which is the optimal split. But there is another concept of binning. Let's say these three we put inside one bin and these two we put inside one bin. Okay, and this bin we call bin 50 to 60 and this bin we call bin 70 to 80. Okay, so originally there were 5 candidates to check the split. Now there are only 2 candidates, bin 1 and bin 2. That makes algorithm run faster, and this what I explained you just now is called histogram or bin way of splitting, and that is the first thing that makes your LightGBM fast. Okay. Second thing that makes your LightGBM fast is something known as exclusive feature bundling. Okay. What is exclusive feature bundling, guys? Let's say you have a data. In the data there is a column called male and female. Male takes value 1, obviously female will be 0. Male takes value 0, female will be 1. It will be 1, it will be 0, it will be 1, it will be 0. Okay. What you can observe here is these two features can never be one together. These two features cannot be together one. Okay. These kind of features are called exclusive feature. So what your LightGBM does is it has a concept of bundling these features, and that is known as exclusive feature bundling. So what is bundling feature? So from these two features, a new feature will be created and called as bundled feature. Here I can put 11 for male and 10 for female. Everywhere it sees 1 there, it will put 11. It says 0 there, it will put 10. So what is happening? I am reducing my 2 dimensions to 1 dimension. If I am working with 500 or 5000 dimensions, and I can find out some exclusive features and I can reduce it by bundling, that is going to help me a lot. And this is one of the smart feature engineering that makes your LightGBM fast and efficient. Okay, these are the two things. Third and most important and most unique thing about LightGBM that you should know is known as gradient based one-side sampling. Gradient based one-side sampling. Now gradient, you can simply think it as, just to understand it better, as I told you, right, in your gradient descent optimization, right, suppose you have to go from the gradient is like this, so it tells you go in this direction, which means that your error is large. If your gradient is large, means your error is large. So you can think it as it sees the error and decide how to create this sample. So just to tell you one more time, guys, all these individual models in boosting will use sample of the data, not 100 records, sample. But if you choose that sample smartly, right, then it is going to make a lot of difference. LightGBM does that. How? Let's see. Suppose this is your baseline model M0. Okay, on 500 records you run a baseline model. So how many errors or gradients you will have? 500 gradients. So your gradients will be like G1, G2, G3. How many gradients? 500 gradients, G500. Out of these 500, what LightGBM will do is it will sort it in the descending order. So first gradient number 48, highest gradient record, then gradient number 14 next to that, and it will be sorted like this, and gradient number 120 will be in the end, for example. Okay, now a certain percentage from this 500 records will be taken out, and that will be one part of the sample. Okay, certain percentage, this percentage is normally 0.2, okay, which is 20%. Now how much data you are left with? 80%. From this 80%, randomly selected certain percentage will come out. That number is normally 0.1. I will tell you one more time. All the gradients will be sorted. Top 20% highest gradients will be taken and kept out. Okay, so this is one set, top 20%. Okay, then you are left with bottom 80%. From that bottom 80%, you take bottom random 10%. So this is your bottom subset. Okay, and then you combine these two, and then you create your new subsample. Now what is happening here? Try to understand, guys. If your gradient is low, that means your model is doing good on those observations, which means in this 80% your model is already doing good, so you no need to train these again and again. But in this 20%, your model is not doing that great, and hence gradient is high and errors are high. So your model should learn more of these patterns. So this takes high priority, and sampling is done only from one side, from here right side. That is the reason this is called gradient based one side sampling. Okay, and then you will have this new data set. On this new data set, you train your model, get the gradient, again do the GOSS, and again do the subsampling. Okay, now all these three things together, if you see here, right, how do you do smartly sampling, how do you do smartly feature engineering, how do you do smartly optimization of your split, makes your LightGBM very, very fast, normally 10 times faster than extreme gradient boost. Okay, so my advice to you guys, based on my experience, if you are on your local machine or anywhere where there is no GPU or there is no cluster, right, you should use LightGBM. Okay, use LightGBM, because LightGBM is typically very fast and it will give you very good performance. Okay, I mean accuracy wise. And if you are on cluster, or if you are on GPU, or if you are on server where you have more processing power, then go for XGBoost. The reason I'm saying this is XGBoost is old and has lot of documentation, lot of help and lot of support. Okay, so that we cannot ignore. That is very, very important. So this is all about this video, guys. Now if you want me to create a Python video showing you demo of LightGBM, I can do that, but these concepts were really important for you to understand. I hope you understood all these concepts, guys. I will